for coming in. Good morning, everyone. I'm talking about turning an application UI into an API. So basically, this is a concept based on our use case which we had, and we wanted to build a UI application with a set of components which is scalable and reusable, which was very unique use case. So I'm going to talk about what our use case is and how we built it. Before I start, how many of you here use WhatsApp? Okay, that's a good number. Uh, just add this contact to your list. Take this, copy this number, take a screenshot. I mean, take a picture of this, and send a message to this number saying join space wing hyphen blank. I'm going to say why at the end of this talk. We have a demo, and probably all of us can participate if the internet helps us. Um, yeah, just take a picture of this, and probably at the end I'll show this again, and then we can use it. Before I start, let me introduce myself. I'm Narendra. I work as a senior software engineer at Twilio in London office. Before that, I used to work for Booking.com in Amsterdam, and before that, I was in India. Basically, I didn't start off as a web engineer or a web developer. I started off as a 3D modeling. I was into 3D modeling, 2D animation, and all of that. And what happened was one day my PC crashed, and only software which could work was Notepad. And here I am as a web developer. So that's pretty much sums up my story on how I ended up writing HTML and CSS for life. Um, let me first explain what is an API to bring everyone on the same page. So what I did was, like every software engineer, I Googled what is an API, and I got this as a definition, which is a set of functions and procedures allowing the creation of application that accesses the feature or data of an operating system, application, or other services. I was not smart enough to understand what that means, so I Googled again, and this time I asked what exactly is an API. And I landed on this Stack Overflow answer, which pretty much sums up which is pretty much easy to understand what it means. An API is an interface through which you access someone else's code, or through which someone else's code accesses yours. In effect, the public method and the properties. Now that's interesting because this pretty much sums up any developers using a library or anything. So for example, if you're a library, to visualize what the definition is, you're a library developer, you're building your application, you're building your software, this is your library code, and your software could be used by some customer, and this could be anyone. It could be a developer, it could be someone on the internet, someone random. And if they want to talk to your application or probably use your library code, they need an API, they need an interface, and through which they can access your code and perform some operations. And that is the API, right? And so they can communicate to your library code through an API, which is an interface. To give an example, Movement.js. We all know what Movement. How many of you have used Movement.js? Okay, for people who don't know what Movement.js, it's a library which is used to format date. We all used it, and we all stopped using it because it was heavier on the client side. So yeah, dot format is an API which helps you format the date string which you pass to it, and we don't know what Movement.js does with it, but all we know that what format does. So that's the API in a nutshell. So to put that in a simpler perspective, APIs can be seen as a Lego blocks. If you're building an application, if you're building websites, building softwares, you could see combining multiple APIs and making your own software. So you can put it in that you can take in multiple libraries, you're using different libraries, different APIs, and then you're building your own application. So I work for Twilio, and at Twilio, it's been 10 years. We've been building a lot of backend services, voice and SMS, and we're building a lot of APIs, which the customers use to build their own applications. And it's been a little over a year since we decided to launch our first UI product, which is called Twilio Flex. And what it does is it is used to build their own contact centers. Now, so what is contact center? Every time you call up any customer service, on the other side, the agent would be probably seeing this UI, and they'd be getting the task, which is the voice, which is a call task or an SMS or any of those sort, and they reply to it. So the logic of which agent gets the right task. That's what this software does. And on the UI front, any customers who's using that could manipulate or could change any aspect of it on their needs. So this is the application which I'll mainly be talking about. To get the context smaller, this is one of the component which is used in Twilio Flex. What it does is nothing but it's a chat application. It knows that there is a chat going on with the customers, and there are three main components. And if you're building this, you'd see this. There's an header which lets you control the chat, end the chat, write a feedback for the chat and stuff like that. There's a list which basically lists all the messages, both from the client, both from the customer and from the agent. And there's an input box which is lets you type the message, right? So if you're a developer who's building this application, you'll probably build these three components on the top level, and internally it does a lot of magic. And you tell your consumer, your customer, to wherever you want to use this component, you render this, right? It works. Now your customer, your consumer probably comes back and tells you, oh no, I want to pass the message list from outside. I want to use this component, but I don't want you to control the message list. I will tell you what the message list, and you give me the callback when someone types the message. So you're like, cool, I'll give you two props, a message list and a callback which says on send message, what the message you'd get. And this is basically an API, right? It lets you interact with your chat component through these two APIs. So this is an API. And this works for this customer. Now you have another customer which says, oh, I want to control the way the messages are rendered. And way the messages are rendered in different format, which is if it's a text, if it's an image, and if it's so and so. So you're like, cool, I'll give you a callback. I'll give you three callbacks, which is render message by default. If it's a text, I'll give you a text, and if it's an image. And if you don't provide it, I'll render by default. And this works. And this can go on, and you can end up with a list of APIs, right? You can end up with, and all these are actually valid. Message, placeholder, loading screen, avatar, bubble, all of this is pretty much possible. And if you want to pass anything to your children components, like here you can see the image and the video props, which is down at the bottom. So you'd say that, oh, give me an object which is a props for a child component, and I'll pass that props down there. And this was not scalable for us because we could not build multiple components, and from the top level we couldn't send that. So that didn't work. And there's another other pattern, which is compound components. How many of you know what compound components are? Okay, for people who don't know compound components, let me explain what it is. So basically, it hides all the complexity at the business logic, and it lets you control how the UI would look. It lets you rearrange stuff in the front end side and the UI side, and it also lets you replace certain part of the components. Now, so if I have to build this entire thing based on the compound component structure, I would build it in this way, where, okay, the chat is a component and it has three main childrens: header, message list, and message input. And if I want to replace any of that, I would replace the message list internally, and I'll pass that. And if I want to replace message bubble, I'll make it something like this, where I'm passing the custom message bubble inside the message list, and the message list renders. So basically, you can change the part of change the way the UI looks, and also rearrange the way you want it to. This works, but this is the application we are trying to build, and everything here is a component. And if we'll end up something this. So if you want to change something deep inside message list from the top level, it goes really deep. So we didn't want customers to mock the entire structure of the tree and to change just one component. So what's the solution we did? So yeah, to come back, this is built entirely with React, and everything here is a component, right? And we wanted two main things. One, that this particular application should work out of the box. That is, if they want to render flex, they just add that component and it just works. And if they want to change any aspect, probably a component which is an icon in any of these components, they should be able to do that easily without going through entire flow. So we introduced something called programmable components. And there are three main things which we wanted to achieve with this programmable components, which is at any part of any hierarchy of the tree, we want customers to be able to easily add any child, which should basically behave like it's already part of the tree. It should not be something like an iframe where it looks like it's there, but it's not part of its surrounding. It should be looking like it's already part of that children. It should get the props what the other siblings are getting. So yeah, so that was one thing. And second is if they don't want any of the native components we are giving, they should be able to replace that with the custom one. And the custom one should behave like it's already part of there. So it should behave like it should basically get the props what the actual one was, what the replaced one was getting. And basically, and the third one is if they don't want any components, they should be able to remove them. Now, to give another example, message bubble is a programmable component, which we have. And by default, message bubble renders this, which is very simple, which gives you the name of the person who sent the message, the time when the message was sent, and the message body itself, the text. Which can be divided into two categories, like a header and a body. So I'll go through the APIs first and then explain how it works internally. So to add a children, every programmable component has a static property called .add, which is a static function. And anytime you want to add any components to the message bubble, you say message bubble.add and you pass the component right there. And this can be done on the top level. This can be done before the application is initialized. And what it does is it just adds that one component below that. So whenever message bubble is rendered, it knows that, oh, I have a third child which I need to render, and it passes all the props which it passes to the its other children. And TimeAgo will get its message props, and it will render the TimeAgo the way you want it to. And if you wanted to render it in a different order, you can also pass another property which says sort order -1. And by default, the sort order, it will pick the component which it is, and it will render it in the position which you want. So that's another requirement where they want to render a component in any position they want in that hierarchy. And if you want to remove a children, you need to know which children. So there are three items here, which is the TimeAgo which we added, the header, and the body, right? Now, to remove any child, you just have to know the key of the child you want to remove. And it's another static property .remove on that component. You do a .remove. I don't want to show the header, and you pass the key to it, and the key and the component just disappears. And if you want to replace this entire message bubble with you don't care about its children, I want to replace the entire component the way I want it to be. And what you need to do is it's the same .replace static properties, and you pass the new component you want to it, and it will replace the entire component with what you want. And the whole hierarchy is different now, but it behaves like it's part of this existing application. So how does it work? So I'll recap with the APIs first. So the message bubble here is extended. It's just a React component, but it has few other static properties, which is .add, like I explained, which takes the component as a first argument and the option parameters to sort order and everything. And then the second one is the .remove API, which I just showed, where it takes the key of the component which needs to be removed, and then the replace, which takes the component and the option. Just like the add, but what it does is it replaces the entire component. Now, how does it work? So when the message bubble is about to be rendered, when the message bubble is triggered to be rendered, it first looks at its own children, list of all its children. In the first case, here's the header and the body. It takes them, it puts them in a separate location temporarily. And then it looks at the list of components which was added through .add API. Right? It takes all that, and all that is stored in another private variable, and everything is kept there. So it takes all the ones which is stored which was added through .add, and it puts them together. So now you have a list of components. Now this component is also passed with the sort order, right? 0, 1 by default, and you have passed the sort order, which was -1 with the TimeAgo. Then it looks at the sort order and it sorts those components. And all this is before the actual rendering has happened. It sorts them in the way the customer has asked. And then it looks at the list of components which needs to be removed. And here it has all the keys of all the components which I need to remove. It matches with the key I want to remove, and it removes that component. And now you have the final list of components which needs to be rendered, and then the actual rendering happens. Right? So this is one aspect of our programmable components, and this is how it works. I'm going to show it in action a little later. Uh, Before that, let me explain you how a different thing which we built called action framework works. So what is action framework? So any action performed by the user on the UI performs some operation. So you click on a button, it performs some operation which is an handler attached to that. So we wanted, our customers wanted to hook into those actions. Basically, they wanted to perform something before the actual handler is executed, or they want to perform something after the handler is executed. I'll show you an example. So what we call this is as a call canvas, which is basically when an agent is having a call task, when the customer is called in, and it has a couple of actions, which is hold the customer, mute yourself, open a directory to show to transfer the call to somebody, and end the call. So all of this is an action, right? And for example, if we take end call as one of the action, when the flex initializes, by default we attach a listeners to each of these actions. And what it does is nothing but it calls another Twilio SDKs to say that, oh, the end call was triggered. Please disconnect the voice. Please change the task status and stuff like that. So customers wanted to hook into before and after the handlers. So what they wanted to do was, let's say, for example, an agent is trying to disconnect a call who is a VIP customer, and we're not supposed to disconnect until the customer is happy, or things like that. So they want to check what is the task status, and who is the customer, what is the things around this task, and only allow the handler to be executed if the conditions match, otherwise show a notification and things like that. So what we did was we provided a listener, action.listener, and any action you want, you just have to prefix with before, and the listener would get two arguments, two parameters, which is payload, which is the actual payload which the handler would get, and an abort function. Now abort function will be used if you don't want the handler to be executed. So here you can actually do all your checks you want, and then only trigger abort function if you don't want the next one to be executed, or you can actually continue doing it if you don't execute abort function, the handler gets executed. And also they wanted after. So after is something that, oh, the end call got executed, now you want to open a survey, or you want to send the survey to the customer and things like that. So that can be put here. So you get the payload which has all the information about the task, about the customer, and you do anything which is needed to be done after the task was done, after the action was done, which is end call here. And also sometimes the customer wanted to replace this entire default handler with their own handler. Here in that case we give them an option where actions.replace action and pass the action name, and the listener would get again two things, which is the payload, which is what needed to decide what the handlers were supposed to do, and also we would pass the original action, which is the original handler attached. And why is that? Because again they can take a decision whether they want to execute their code or they want to execute the actual default handler. So I'm going to show the things which I spoke in action. So I'm going to do a small demo. So if you have not registered to this number through WhatsApp, do that now. Just add this contact onto your WhatsApp, send a message which says join, and you'll probably get back a message saying that you have added to a sandbox group. Basically, you added to a group so that you can be part of this demo. Let me just go and change. Yeah, let me mirror display. Okay, so I could have actually picked the one which we have. Instead, what I did was I was going through fun applications to play with. So I found this React Tetris open sourced game, which is basically a Tetris game built with React. And I forked this repo and I made some of those components programmable, basically giving them the static properties which I spoke about earlier, and made it look something like this. Now, yeah, so it works, right? But you want, so I made them programmable so that I can change the way my team would want or someone. So basically, so let's see what to do. Let me just open components. Okay, so it has a decorator left, it has a main component, decorator right, and the keyboard. Okay, so by default, this is what the application does, right? Now, what it does is you're just rendering tetris.app. You can see the screen, right? Yeah, cool. It's too close to me. Let me do one thing. Yeah. So Tetris app does nothing but renders this entire application. And as a consumer of this app, I don't really care how this is built. All I care is it useful for me? And this is what it does. But my designer, my product manager comes and says, oh, we don't want this keyboard. We don't want this decorators, how it looks. We want to change the entire thing. And what you need is you want to remove these components, which is left, right, and keyboard. So let me remove that component. So before rendering, you can actually say that Tetris dot app dot remove. So I want to remove what's the keyboard. So as you can see, keyboard, the key I need to pass to remove that component. So I'm going to say keyboard and remove. Okay, I think first thing is okay, the keyboard is removed and it's not even part of the tree. It's not just hidden, but it's completely removed. Now I'm going to remove the left and the right as well. So decorate, yeah, decorate hyphen left. Okay, someone's already connected, I guess. Yeah. Okay. Okay, not supposed to play now. Yeah. Anyways, so I'm gonna first remove this decorate left and right. So it's gone. But you would probably have, yeah, you'd probably have a scenario where your designer would say that I don't want the way it looks. All I care about is this component. Okay. Now what's that component? Stop. Let me mute that for now. Okay, so this is a screen component. This is an entire main component, but all you need is this matrix, right? So I'm going to remove the main component, and I am going to add the matrix component. You know what? I'll turn off my Wi-Fi so that I don't get the request you're sending me. And we'll do that later. Uh, Tetris dot matrix. I'm going to use the same component which the Tetris provides me, and I'm not going to create anything. So I'm going to create, and I have to pass the matrix. Okay. Yeah. So now, as you can see, I've removed most of the things which the application provides, but only used what I want, and everything works like the way I want it to. Right now, what the designer probably says that, okay, I want these cells to look different. Okay, fine. And I'm first gonna change. So, okay, so let's see what the cells are. So everything, okay, let me go into the components. Everything is a cell, right? So I want to replace each of this component. First thing first, I'm going to say tetrix dot cell dot replace, and I have a new cell, I guess. Yeah, I have a new cell. I'm gonna pass new cell, and new cell does nothing different than it takes the status, it decides which cell to be passed, and these are nothing but just blocks. It's just a different background color, the same thing with the new blocks. And then when I save it, I come back here, I have the same thing, but with the different. So the whole thing just still works. The business logic still is the same, but the UI is different now, right? Now let me go back and I'll change the background color just so that it looks better. So the same thing app, I'm just passing that. So you have the game. Now you would probably want the score to look different. So you would say, I'm going to add application dot add new score. And new score is little complicated than that, but it's nothing different. So what it does is it gets the same set of props which the components otherwise gets, which was already there, and it just renders the label, and it again renders the component which is part of Tetris itself. So not doing much of a logic here, but it's just a UI change. And you have these two components, which is, and the cell, since I've replaced cell here, the cell still behaves like it was a new cell here. And everything just works. Okay. Now is the time where we all play it together. So I'm going to add new, what's that called? I have it written down here. It's called rules. Rules, I pass the rules, and the rules will be rendered somewhere here, but I want it on the left side. So you can do pretty much this, sort order -1, which I said, and it should render on the left side. Let me connect to internet now. Let me connect to my phone. Okay. Sorry. Come on, yeah. And now, wait. Yeah, let's see if we can play. Start sending numbers, messages. Yeah, there you go, something's happening. Let's see if we can make a line at least. All together. Let me see if we can. Horizontal. Okay. Okay, we'll get another try. Okay. Let's see if we can probably try and play together. And so what we're doing here is using the WhatsApp API of Twilio and getting all your inputs, and it goes to the server, which is at Twilio, and it sends it back to the client here. And this talk will be done once we all get one line, hopefully. Oh no. I don't think I have enough time to play another round. So yeah, that's it. This is my Twitter handle. If you have any questions around that, please ping me and I'll be happy to help. Yeah, that's it. Thank you very much.